37. The theme for this month is soft robotics. And last time what we did was we got a general overview of different kinds of soft robots that we have. We talked about the octopus inspired soft robots. We talked about inflatable robots and other kinds of soft robots. And today what we will be doing is we'll take one specific type of soft robot which is actually inspired from the movie Big Hero 6 called Baymax, and we will try to deconstruct it, or rather build it together in a by brainstorming about it. So let's go. The agenda is the same as always. So I'll just skip to the main part. There are a lot of roles that are open currently, and you can check those in the assign roles section. So let's start with building Baymax. Sorry. So what is Baymax? First of all, let me first get your feedback. How many of you are already familiar with what Baymax is? How many of you have seen the movie Big Hero 6 or at least heard about it?
I've seen it. It's good.
Okay.
Yes, I have also seen it.
Okay. So you guys are already familiar with it, right? And is there anyone who has no clue about what Baymax is and has heard about it for the first time? Okay, I think like everyone has at least heard about it, if not seen the movie. So I think the movie is also pretty interesting if you want to watch. So what is Baymax? Baymax is essentially a soft robot, and as you can see here, this is the character from the Baymax movie, the Big Hero 6 movie, and it's essentially a soft robot. And what do we mean by a soft robot? By a soft robot, we mean that it's a movable robot, but it's the parts, the components that it is built up of it are actually deformable. So it's a movable robot with deformable parts, and it's inflatable robot. That means that this entire structure is actually sort of like a balloon or an inflatable tube. It's more similar to that in the sense that the membrane or the skin layer is actually something that offers resistance, tensile resistance to stretching. So it prevents stretching it too much, and the material is chosen such that it stretches only how much it is required. And then we also have pressure difference, since generally air or some kind of a fluid is filled inside this structure, which means that pressure difference actually provides resistance to compression. So if you press on it, you get the idea, right? It's balloon. And what was interesting was that this from a mechanical structure point of view, there's these space suits which are already actually based on inflatable technology. So they are inflatable, these space suits, and I didn't know about that before. So this is one part. Now for those of you who are not familiar, or even if you are familiar, we'll watch a very small clip of introduction to Baymax, and maybe you can let me know if the audio is clear, because we'll be actually defining the features of Baymax based on the introduction in this video. So can someone confirm me if the audio is clear from the video?
Hate to break it to you, bro. Already been invented. Hey. Dude. Ow.
So is the audio clear? Are you able to hear it?
It's a bit feeble, but yeah, I think it will work.
Okay.
Most of the time, it's just a white screen. I'm unable to see anything.
Oh really? So could you see the slides and everything that I showed before?
Right now,
But
I'm able to see, but I don't. Sometimes it just goes white and everything goes like.
Okay. Right now, are you able to see?
No, right now, no, I'm not.
Okay. Just give me Yeah, I don't know. There's some problem with streaming every time. Yeah, it's actually widescreen as I can see here. Maybe let me try again. Okay, now can you see like the slides and everything?
Now I can.
You can.
Yeah, it's kind of fluctuating, but it's okay.
Okay.
So, what have you been working on?
I'll show you.
So how about the audio now?
Duct
Yeah,
tape?
audio fine.
Hate to break it to you, bro. Already been invented. Hey. Ow! Dude! Ow!
This is what I've been working at.
Hello, I am Baymax, your personal healthcare companion. I was alerted to the need for medical attention when you said, ow.
A robotic nurse.
On a scale of 1 to 10, how would you rate your pain?
Physical or emotional?
I will scan you now. Scan complete. You have a slight epidermal abrasion on your forearm. I suggest an antibacterial spray.
Whoa, whoa, whoa. What's in the spray specifically?
The primary ingredient is bacitracin.
It's a bummer. I'm actually allergic to that.
You are not allergic to bacitracin. You do have a mild allergy to peanuts.
Not bad. You've done some serious coding on this thing, huh?
Uh-huh. Programming with over 10,000 medical procedures. This chip is what makes Baymax Baymax.
Final?
Yeah, going for a non-threatening, huggable kind of thing.
Looks like a walking marshmallow. Oh, that's
I am a robot. I cannot be offended.
hyperspectral cameras?
Yep.
Titanium skeleton.
Carbon fiber.
Right. Even lighter. Killer actuators. Where did you get those?
I machine them right here in-house.
Really?
Yep. We can lift 1,000 pounds.
Shut up.
You have been a good boy. Have a lollipop.
Nice.
I cannot deactivate until you say you are satisfied with your care.
Well then, I'm satisfied with my care.
He's gonna help a lot of people.
Hey, what kind of battery does it use?
Lithium ion.
You know, supercapacitors will charge it.
Okay, so that was about the clip. Maybe let's do a small brainstorming session about the clip now. So, what were some interesting points that you could find from the clip, and like take into account that if you were to build something like this from in actual, what are the things that you would consider? What are the features of Baymax that you would look at? So we saw a lot of things that were mentioned.
Excuse me, the presentation is white again. The slide is.
Yes.
Yeah,
I think you're
okay.
right.
Yeah, actually, I think, when I zoom out to actually see the chat, then yeah, it goes wide. Now you can see it, right, again?
No.
No.
Okay, but you did see the video or not?
Yeah, yeah.
Yeah,
Okay.
video was there.
Yeah, okay. Just a minute. So it's just, I think I got it. Now it should be visible, right? Or no?
In between, I mean, it's fluctuating.
It comes and goes.
Okay. So just wait for, let's say, 5 seconds or 10 seconds or something. I think, it takes some time. I think it should appear. Now, is it widescreen again, or can you see something fluctuating or?
White screen.
It's white.
Okay.
So,
Okay. Anyway, I think you don't need to see anything at this point. So I'll reshare it again after this. So now what we are doing is we are brainstorming, and we are going to discuss what you think might be the features of an actual Baymax if we would be building. So yeah, what are the components do you think we have in Baymax? So we can actually like categorize into three categories. So one could be the body aspect, the physical aspect. The other could be the intelligence aspect. The other could be actually the understanding the social cues, social interaction aspect. So yeah, any comments? Anyone wants to say something?
How about localization, computer vision, and actuation?
Yeah. That would be in the brain, the intelligence category, localization. Yeah, like we have for mobile robots, uh, similar concept. And what else?
Uh, Localization, computer vision, and actuators. So that all that moving part and everything, and he was able to see the problem in his forehand. So that scanning was done via some sort of vision system.
Yeah. So from hardware perspective, we have a camera as the primary visual sensor, right? And also about the physical structure, what did you observe generally about how the structure is as they've depicted in the movie? And we can also talk about how they are actually designing the actual structure and things like that. But yeah, what were your observations regarding the physical structure?
Yeah, he did said about something that titanium carbon fiber skeleton.
Yeah. So we do have a skeleton as they have mentioned it. So what do you think? Like, do we really need a skeleton for such kind of a system, or like a totally inflatable balloon kind system would also be sufficient? Do you think we need a skeleton? And of course, we'll talk in detail about these things. But like generally, anyone wants to add something?
I mean, like a skeleton is required, right? So the Baymax here, it tends to walk around and find people. So definitely actuators would be there, and that should be attached on the skeleton. So just making it completely inflatable, I'm not sure if this motion would be as simple as like just using an actuator.
Yeah, primarily for walking, I think the skeleton would be needed, right? This is what you're pointing to.
Yeah.
Okay. Okay.
I think actuators are also necessary because if you will see, it's more of a medical thing, which means medical use, which means you need a lot of accuracy. And I think with actuators and things like that, we can control that right to the very finite grade of millimeters.
Yeah. Yeah. For specifically for medical applications, I think controlling it would be an important aspect. Yeah, I think that also makes sense. Yeah. So, any comments about the human robot interaction or collaboration side of things? Because that would be a very important aspect, right? It's dealing with humans, and what do you think would should the primary requirements of it should be? Of course, it should be like safe and stuff, but from a human robot interaction, anyone wants to add something? Okay. Yeah, no worries. We can discuss all the separate aspects in detail now. Now, I hope the screen is visible, right?
Yes.
Okay. Yeah. So, before we go into the components, why do we need to build Baymax, right? This is an interesting question. In the movie, it is depicted as a healthcare robot, and it's supposed to, offer suggestions and treatments based on the 10,000, I think, what was it, 10,000,
Yes.
yeah, medical procedures that it trained on. So it specializes in that area. And I think the actual person, Chris Atkinson, or I don't know how to spell his name, but the main guy from CMU, who is actually in this research, I think it's built baymax.org or something like that, and they're actually trying to build this thing. So they are actually focusing on these two applications. So one is, of course, healthcare applications, and for healthcare applications, the primary requirements are that it should be safe, it should avoid risk of injury to humans, and of course you cannot use an actual robot like a metal robot, rigid links and rigid structure base, because somehow, like, we humans wouldn't intuitively trust those. So of course that is debatable as well. But yeah, this is a major application, healthcare, and the structure of Baymax that they have depicted in the movie also makes it easier to clean, and it can handle bad weather. It's just a membrane based structure. And another important application is similar to healthcare, and it's actually caregiving for elderly people and helping them to eat, wear clothes, and doing these day-to-day mundane tasks. So these are two interesting applications and why it might be impactful, this thing. So now let's move to the features of Baymax. So now is where our discussion on how to design it and stuff would go on. So features of Baymax is like body wise, if we were to, of course we are biased because we have seen the clip and they've mentioned all the features and everything, but think about, like, if you were to build a Baymax for yourself or for the healthcare system, what are the things that you would be considering? So body wise, physically, if we think about it, so what do you think are the requirements? Now these are the requirements that they have mentioned. So it should be portable. We saw that there was a compartment, like a suitcase, where it could actually fold into. So this was depicted in the clip, and it should be lightweight, deformable, and inflatable. This is the kind of robot. But if you were to, like, reimagine, if you forget this structure that is being used, and you're open to a healthcare robot, would you consider rigid links or would you consider a similar structure? What are your ideas? Let's have, I think this would be the interesting part, right? So just feel free to give any suggestions or anything, and I'll just start writing. So let's go from broad to narrow. So a broad thing would be overall, how do you think the design should look like? Like a very crude overall, how the look of it should be, and then we can talk about the actuation systems, materials, and we can go narrow in each category slowly.
I think, in my view, having biped as a medical purpose robot is very cost. It's not very cost effective. So I think a wheel Baymax kind of torso should be there for medical purposes.
So a wheeled structure, but like you still want it human look, but instead of walking you want wheels. This is
Locomotion is through wheels.
okay. So wheeled locomotion, this is something, but yeah, I mean, it does make sense, but ultimately you see the movement of this kind of a robot would not be
Yeah,
That
in
much. It
a
would
very
be indoors and yeah, restricted environment.
in a
So
very structured environment it will be used, but such as in military medics,
yeah, yeah,
like
yeah.
if they deploy like in a very unstructured environment, then biped is or quadrupeds, I don't know. Biped having leg bipeds as uh, a mode of locomotion would be reliable.
Yeah, so but like, why do you think? What would be the advantages of wheeled locomotion then?
I believe in a structured environment having bipeds, like because they consume more power than the wheeled ones,
Mm-hmm.
and there is no need of having biped in a very structured or disciplined environment.
Okay, okay.
Because
So, like, still for unstructured environments, I think it would be like we can take the unstructured environments in our case study today. I think, but you mean you're suggesting wheel locomotion for a structured that would be better, right?
like
This,
hospitals or offices, yeah, yeah.
but like I think hospitals or offices, I think. Unless you are providing a model or something, they're also not really structured, right? I mean, even if you're providing a model, they're also not structured. In what sense do you mean?
Uh, the traversing path. I'm talking about terrain.
Yeah. Ah, okay. Terrain wise, but like ultimately, if you see that in any kind of environment, yeah, terrain wise, okay. Terrain wise, yeah, I get your point. But like apart from that, there would be like obstacles and things moving around. So I think the environment would be unstructured. I think we can
Yeah,
categorize it
yeah,
as, yeah. But
yeah.
okay, you're talking from a terrain point of view. Okay, interesting. Yeah. Anyone else has any other view that what kind of thing would make more sense?
Uh,
I'm
I
okay.
think if please go ahead.
No, no, it's fine. You
Govind.
started.
Okay, so I think from motion point of view, I think you chop off the leg and put anything based on the terrain, that is completely fine based on the
Hmm.
requirement. But what I prefer is that this upper torso has to be there, because if you will see, even in today's world care healthcare systems, one of the reasons why people don't go for robotic based things is because it
Hmm.
looks more tentacles and very war machine kind of a thing. So that look of comfort has to be there, because in hospital you may find people with in lot of shock and things like that. So
Ah, yeah.
this
Yeah.
idea of calming them is very important, I think so. You
No.
want to put it in whether you want to put it in a building or in a war zone, it's completely comfortable with whatever kind of a locomotion you provide to it. But
Yeah. Okay. So like there are two aspects of it. I think like one is about the, I don't know which color to use, so I'll just take any. Yeah. So there's two aspects, right? So one is the terrain part of it, and another is the look, I would say, right? So maybe I can write the terrain that we are considering. So one this is like how we would how it will move in its environment basically, and the other is the overall look. So we can probably divide it here. So this would be
user experience.
yeah, yeah, I think that would be a user interface, let's say.
Yes.
And then it's mobility or locomotion mobility, and this depends on the terrain that would be using. And yeah, so for this it's so Baymax is designed to be like look totally innocuous and like not harming anyone, and be yeah super friendly and stuff like that. So do you does anyone also believe that making it like realistically look like an actual human would be a good idea for this case, because like that would probably like psychologically help connect with the patient somehow? Or what are your views on that? Like we are just throwing around ideas, so like if the robot actually looks like a humanoid. uh, I mean, in my view, I think it would be if the humanoid look is actually very realistic. Maybe in the far future, the skin membrane and everything, and we are able to do it very realistically. That I'm not sure. That might be a good idea, but at the same time, it's about the uncanny valley, or is it called, or uncanny zone, or is anyone familiar with the term? I think uncanny valley is how is it called, right? When the robots resemble the real humans too much to be creepy.
Uncanny. No,
Yeah,
but see, it's my point being, it's not. It has not. I'm not saying that you have to, make it completely. What you call this human looking, like what you have that Dubai-based robot. I forgot her name.
Sophia.
Yeah, Sophia. It need not to look like that, but
Yeah,
if you look these now robots and all,
yeah,
uh,
yeah.
they are made of plastic. It has nothing to do with membrane and all. If you'll see, it has a wheel-based motion, but on torso it has more of a humanoid touch. So now that is it. If you look at that design, it's very much, I'll say, calming compared to having a lot of tentacles coming out of a box.
Okay, okay. Yeah. So, according to you, a plastic. So, even if like we have this look, and maybe let's say we have a rigid structure made of plastic or 3D printed materials or something, but it's a rigid structure. Do you think that would be still a good idea, or do you think no? We should always have like a soft kind of a system.
That is again, I'll say it's debatable based on where we are putting it and things like that.
Yeah. So maybe let's fix our condition to just out of these. Let's say we are talking about caregiving for elderly. Let's just take this one specific thing into account so that we can focus on one domain. Yeah, and not we don't get scattered it too much. So in the case of like caregiving for elderly person, I think the robot would be in direct contact with it, with the human, and maybe helping the person feed himself or herself or something. And in that case, I guess like of course soft would make more sense.
Yes. Now that is a specific case where I see that made up of something like this Baymax
Yeah.
squeezy stuff will make sense because I mean the way we give help to any elder is generally a direct physical contact where you help them to stand up or sit down, things like that.
Hmm. Yeah, okay. So we have talked about how the base structure would be the terrain, how the look would be, and another thing would be the concept. So here, what they're based on is basically it's a pneumatically driven system, right? And it's inflatable system. Do you think some other concept could be interesting apart from that? Actually, of course, Baymax is like the picture is in front of it, so we are already biased. Maybe it would have been better idea to discuss all of this beforehand, but still. Any suggestions on the concept? So if you were to make different kinds of actuators, let's say in the robot, do you think motor based system would be a good idea, or hydraulic? Of course, that would already make it too bulky, but any comments on actuation specifically?
Motor based would be noisy, right? And you know, lot of problems with that. So I don't know how much motor based would work.
Yeah, at the same time, it would make it heavy as well, and one of the things that they have considered is portable. Do you think portability is an issue, or it should be a requirement? Like they showed that it could be packed in a suitcase, or that's really not needed. Maybe it's supposed to be once you have it in an environment, let's say home or a healthcare place, then yeah, it stays there. Do you think portability should be a requirement?
Till I think portability will be more of a point when we, go towards extreme ends. Now, if you say in the hospitals, in a building, I don't think portability is required. But if you put it in a war zone, then portability is one of the important issue, because a soldier is applied how much?
Yeah, yeah.
Maximum he can take 25 to 30 kg. The maximum weight they load onto them when they go full gear. So the 25 to 30 kg is the limit. So we are thinking of at least one person who will be putting this machine on top of him.
So for military scenarios, it makes sense, but generally for the caregiving one, I think it doesn't make sense, right?
Yeah, that's my view. I'll really hope there is anything more.
Yeah, yeah. Anyone else wants to add something, anything related to the physical structure? And now, so far, what we have done is only the external. We can also talk in detail about the skeleton and about whether we need a skeleton, because this is an interesting point actually. So the research that they're doing at CMU, they are, I think, considering, they have been considering both kind of structures, so without a skeleton and with a skeleton. So yeah, details of which I think, I don't know the specific details. I think about the structure one, they do have a pneumatically based actuation, and actually, in fact, the actuation is also inflatable kind of a system like we have in our muscles. So these, um, let's say this is inside the arm area or something, and then these are inflatable and pneumatically controlled, so even the skeleton is very, very lightweight in the structure that they have built. So yeah, any suggestions on the structure? I think I can try to open up a picture of the structure. So Baymax, build Baymax. If we can just find in the, yeah, exactly. So here you can see the way, and this is the blog that they have actually specifically dedicated to Baymax. So initially they were just putting it on another robot from CMU itself, but ultimately they also are considering the skeleton to be very lightweight. Yeah, here is the skeleton. So lightweight carbon fiber skeleton. So this is carbon fiber skeleton, custom built pneumatic artificial muscle. So this is what I was talking about, artificial muscle and its actuation behavior. 2 degrees of freedom joint used at both shoulder and elbow. Under actuated multi fingered gripper with 2 degrees of freedom wrist joint. So this is the kind of system that they have. Anyone wants to add their comments on the actuation thing? Okay, yeah, I think we're already biased with the structure now. So about the body portion, does anyone want to add something? Otherwise, we can move to the intelligence part of it as well.
I
Okay,
think Govindam was giving some points.
sorry.
I think Govindam was giving some point and I interrupted him.
Okay, yeah, go ahead.
Oh, I was just like, we've covered this already. I was just thinking about, so if this Baymax, it doesn't actually perform any medical procedure. All it does is uh, finds out the problem, basically. And for small things, it can rectify, but it doesn't actually perform a medical procedure. So, like, I was just questioning the need for the arms. We could just fit everything into the just the body, right? Because it's kind of a bulky body. Why would you really need the arm?
So
Some kind of
yeah, go ahead.
might require movement using the arms as well.
Sorry, could you
Because
repeat?
I think I don't know much about medical diagnosis, but maybe some kind of diagnosis might require the movement of the patient's body parts. That should be done via arms.
Yeah, I think this the first aid and the first responders, they generally, you as a first responder, first aid, you will need a arm, right? I mean, all the sometimes, let's say if a person is hit on a back, and if you just need to have a look under
Mm-hmm.
that condition.
Yeah.
Could you
Uh,
repeat? I didn't get that.
No, so I'm saying places such as first responders, even inside building, you have this first responders, right? As soon as a patient comes in, there will be a set of nurses and some initial doctors who will make a quick diagnosis that what is going wrong, and they will make a quick update that what needs to be done, and then obviously some main person will come in and will take care of the patient. But that initial diagnosis, that at that point of time we need a tool which can, if required, can actually look through. Let's say some bus accident happens, a person comes in with a bloody hand, with a full t-shirt, full sleeves, then at least a hand which can cut through the sleeves and tell that okay, this is the problem area. It can be that simple.
Yeah, so that's what I was saying. So, like, this hand that could cut through the whatever, that's a medical procedure, right? We don't actually see Baymax do any of that. So,
Baymax is more of an example, I'll say, just building on top of it. I
okay,
think
okay,
that's the
yeah.
idea.
Fine, yeah. Then,
yeah.
yeah, in those cases, like, hands are obviously useful in a lot of cases. I'm just questioning the need when the way I see Baymax is just it just goes around and scans people and tells you if you have any problem or issue. Like,
If you see that he sprayed some liquid also on top of his hand to make it good.
Yeah, yeah. So
okay.
it does perform those, I think, very preliminary first aid operations as well. But it detects right from the sound out that we saw in the clip. It detects that yeah, somebody needs me, and then it does the diagnosis and then does the procedure. I think the procedure that they have shown in the movie is of basic nature, and I think the medical procedures that you are talking about are like proper, like more advanced things. I
Yeah,
think
like surgery and stuff.
surgery. No, I don't think. No, I don't think this is suitable. It's for general health care and household or in the clinics and stuff. It can scan and do minor things. I don't think it's for surgery. So I think surgical robots can be rigid as well, right? I mean, doctors have to learn, interact with it. So it's not inside a house, right? It's inside an ICU or inside a specific setting. So I think that would be a different kind.
I think as an initial example, we can think of someone who can apply Volini to a part where our hand cannot reach.
Okay, yeah, yeah. Yeah, any comments regarding the body? Anything that you want to add? Because then I have actually jotted down a bunch of points from the actual blog that I shared, and what they have actually considered in the design of the real Baymax, so to say. So let me go to the headline. So about material of this we didn't talk. Does anyone have any comment? What kind of material can we use? So we talked about, yeah, softer material, stretchable elastics and all these kinds of things would be probably suitable, and plastics or 3D printed objects or rigid bodies would not be suitable. So any comments regarding the material? Okay, and about sensors, we didn't talk at all about sensors. So, in the laboratory that they are working on, they also have one really interesting kind of sensor. So, I don't remember the name, but those are on the membrane, so on the skin of itself, and then as the skin stretches or compresses, then the sensor gets the reading accordingly. So they are membrane based sensors. Do you think there's and apart from that, like of course we have camera for identification of the surrounding objects and stuff. So any other sensor that you think might be benefit here, useful here? Okay. So we can go to the points that I have right now. So yeah, so the body shape, the screen is clear, right? Because right now I'm not doing it full screen because I have points outside of it. So it's
No, it
clear?
is visible.
Yeah,
Yes,
okay.
visible.
Yeah, let me know if something is not clear. So yeah, talking about the body, there are a couple of bunch of things that you can consider. So one is about body shape, right? Do we really need it to look this like with belly fat and like do we need this kind of a system? This is designed primarily with the motive to make it look safe, right? So this is one thing. And let me see if there is any point specific to body shape. No, so yeah, I don't have any specific point, but I think we have discussed it. Any other addition related to that, related to body shape?
I think one of the reasons it's made like that is for the purpose of hugging. So we see Baymax
Yeah.
hug many times, right? So if it's not inflated, it would be very uncomfortable, right? I think
Yeah,
for the
yeah, yeah.
purpose of comfort.
Yeah, I think that's a good point because yeah, it's kind of like a pillow or something, right? So the person would feel safe with it. Yeah.
Don't you think that it's a hypothetical concept right now?
Yeah, in the movie it is, but there is actually research going on, and of course, currently it's not like in production. It's in research, and there are people who are working on it and actually trying to make this reality.
No, no, I know about that. I know about that. But the problem which I think so would be there is we don't have really that kind of actuation available right now.
That kind of what?
Like actuators.
Actuators. Okay.
Yeah,
I
yeah.
think they have custom built their actuators, right?
Yeah, exactly. That is the point. So even the actuators, the skeleton, everything, they are building on their own. So this is as we saw. So
No,
this
no, no.
is
What I have seen on their site is they were trying to put a balloon kind of thing on like over Atlas. So they were trying it that way.
so this was, I think, just a very demonstrative concept. But eventually, I think this is what they built internally because this is too heavy. This is too
You can see on
heavy.
their site as well. They were trying to basically, yeah, keep a balloon over Sarkis and
Yeah.
Atlas.
No, I agree with you. I agree. This is what they did. But this is like they've tried out different concepts. Does it make sense? So this is one thing that they tried out. So since this is like a very novel thing, right? Nothing like this already exists. So they tried out a bunch of things. They said,
Now,
okay.
one more thing which I wanted to ask is, how will it, in the movie it used to basically contract and fit itself inside a case. So
Yeah.
how will be that happening in real?
Exactly, and I
We
think
want it.
this is the point. This is the reason why they've made such kind of a structure. right? Because this thing can be folded very easily. It's very compact as compared to, if you use such kind of a thing. This is not possible to fit inside a suitcase. So this is also, I think they've mentioned it
No,
here, right? Should be lightweight if
kind
you
of
must
structure
have a
they're showing
skeleton.
on their site,
Yeah.
the kind of structure they're showing in on their site, are they working on that in reality, or it's just an concept?
No, they so this
Because
structure
I
is,
haven't seen any kind of.
they're working on this in reality, right? So this is a blog by this professor, and they are
I
actually
know his name,
building it.
Yet
Yeah,
Kesson.
yeah, exactly.
Yeah, no, I have seen about this already. But what I'm trying to ask is like, what is the real work going into this? Because it's not mentioned anywhere. They have just made a site.
So the thing is, this is exactly the real work. If you want to, if you're asking about on the research institute or specific website, I think this is they were also asking for crowdfunding of this project, if I'm not mistaken. Yeah. Uh, so they're actually asking, they have this campaign running, and they want to do it by means of that. But is it a part of research institute and funded in that way? I'm not sure. I don't think so. But yeah, I might have missed something there. So yeah, does it answer your question?
I think he disconnected.
Okay. It was okay. Yeah. Anyway, moving to the main point. So this structure is totally balloon kind of structure, so no rigid parts inside it. And then we have super light skeleton, pneumatic actuators to make it light, electric motors not used. It's still in ideation. Distributed sensors, so the sensors are like on the membrane. I think like Apurv, you were there last time, right? So we saw something like that last time, right? The skin sensors. Okay. So apart from this, about this I couldn't find much. So this is like hyperspectral cameras they mentioned. So I'm not
Yes.
sure about this. Anyone has any idea?
Hyperspectral camera means basically your camera which is capable to visualize beyond your RGB spectrum.
Okay.
Hyperspectral generally also means that when you go beyond infrared. So
Okay. Interesting.
so I
Yeah.
basically you have multi-spectrum cameras or hyperspectral cameras. I Your CMOS sensor is basically capable of capturing any spectrum. So what happens is, on top of your CMOS layer, they add a physical filter called as bare layer,
Okay.
and that layer actually helps you to contract only visual spectrum. So that's how you get a just RGB colors. But in general,
Oh,
because you have electromagnetic wave everywhere, so complete spectrum is always available around you.
Okay. So is there really a need for this kind of a thing for healthcare systems?
uh, well, I'm not sure about this lower spectrum, but if you'll go towards this RGB, not RGB, infrared and all, sometimes they use, I
Hmm.
mean, like this, they use it for temperature things, and
Yeah.
microwaves are used for your scanning.
Yeah,
So
and okay. Now it makes sense. So so it can also detect like the health conditions, right? Like we saw. I think that was a bit too far fetched about detecting allergies and stuff. I don't think that
yes,
is possible. But probably
Yeah,
temperature, and maybe like if you have fever or
temperature,
something.
broken bones, these things something
Yeah,
that can give.
yeah, yeah,
Yeah.
yeah.
So, are these hyperspectral cameras real? Or
Uh, I'm aware that there are some spectral cameras are available. I'm not sure hyperspectral are still available or not. Yeah, it's there.
okay, so this what basically this hyperspectrum spectral is, it can capture all rays from the spectrum, right? The
Yes,
entire
yes, yes.
spectrum.
Multiple
Hmm.
spectrums.
So like I'm not exactly familiar, but what it looked like in the video that it got an X-ray of the.
Yeah, so
Yeah, yeah, yeah.
for your
So
X-ray, you need those that particular spectrum, right?
yeah,
So
but how, like I'm not sure how, like the X-rays. So when we go to the hospital, they take a X-ray, right?
yes.
So over there, they are passing, like they're making the X-rays, no?
Yeah, so if you'll see the X-ray imaging, the way it works is you are basically bombarded with the X-rays,
Yeah.
and on the other end, you are they just collect it, and the part where your rays cannot penetrate is basically you get a image for that much
Okay.
part. So
So this
broken.
yeah, so this hyperspectral camera just collects the rays, right? It does not produce them.
Uh, it depends. I mean, like, see, now that's the thing. In see, that was a movie, so in movies, some technical points they must have, not thought of. But it's not compulsory that you have to. If you will see this thing, there is this research going on something called med bed. So it's basically a medical bed where a person lies, and entire MRI and everything is done on a single shot. Everything. But it's
Okay.
think of it as a faster MRI.
Okay. Okay.
So that kind of so yes, X-rays. If you speak for X-ray, yes, then there has to be a collector and has to be there. Or if there is a better way of scanning, so there
Yeah,
is research on microwaves where not microwave radio waves, so based on the intensity, they penetrate certain amount of your skin level, and based on that they have created imaging. Lots of 3D MRIs are doing the same.
Okay. That's interesting.
yeah. I mean, I agree. So I think like the thing would be in this they showed that like the hyperspectral cameras are like normal, very compact cameras, and I don't think in real they, yeah, if they have like a sending end and a receiving end, I think it would probably not be super compact. But like, yeah, there, this is a futuristic and hypothetical concept, so that would be the thing.
You can I'll say you can think of it as a single camera which can do both your RGB as well as infrared imaging.
Yeah.
Think of it in that way.
Yeah. So apart from that, we have, of course, a carbon fiber based skeleton and lithium ion batteries. Um, yeah. Any comment about the batteries? I think lithium ion would probably be a bit dangerous for a healthcare robot, right? What are your views?
I mean, not just dangerous. Like, how would it? I'm not sure how much it could. I mean, the weight of the battery,
Yeah,
basically.
yeah, yeah, exactly. And yeah, that is probably an even more important point. Yeah. So since like we are focusing on portability and lightweight of the robot, and then we are taking lithium ion, so I think this is probably one of the biggest flaws with the way they have like conveyed it in the movie, probably. Yeah, and about the material, I think it's 3D printed silicon material, and actuation can be provided by the same kind of actuators used in rigid robots attached to tendons, or by moving pressurized air or liquid into volumes that can change shape. So so the actuator that we saw here, this is yeah, These are pneumatically controlled, sort of mimicking the muscle movement that we have in actual. And skeleton is what they've written is Blimp versus Zeppelin skeleton. So about this I don't really know, so I have to like Google it. If anyone has any idea, you can comment about it, right? Blimp skeleton. Okay. Blimp skeleton and Zeppelin skeleton. Okay. Blimp versus Zeppelin. Both blimps and zeppelins work by being lighter than air. They're filled with a gas that's lighter than oxygen, so they go up like hot air balloons, but balloons can't be steered.
This is the type of the way aircrafts are constructed.
The structure of the aircraft, I
Yes.
think, yeah.
Yes. I think I can explain blimp.
You know about it?
Zeppelin. I'm just trying.
Okay. Yeah, go ahead. Blimp versus Zeppelin, what's the difference? Okay, I think maybe we can just look here in more detail. I'm just looking for the difference directly. What's the difference? Blimp. Here, I think here it would be. Anyone else? Yeah, here. Main difference between zeppelins and blimps. This is it. So zeppelins have rigid metal skeletons, making them suitable for longer trips in a wider variety of weather conditions. Okay, which also makes them expensive. Blimps, on the other hand, are simply shaped balloons with fins and an engine. Okay. It dates back to and mimics the sound made when the balloon is thumped with a finger. So blimp is actually named on that. Funnily enough.
If has anyone seen a naked aircraft? An aircraft without the outer sheet.
So like this image,
Yeah,
right?
something like this.
Yeah. Mm-hmm.
Yeah, so this is a one way of structure.
This is Zeppelin, right? This is
Yes,
made
yes,
of.
yes.
So the difference is, I think that the Zeppelin is about with using rigid links,
Yes,
whereas
yes.
Blimp is about using these inflatable kind of structure, basically.
Yeah, so
Yeah.
blimp is more of that first balloon kind of you remember, I forgot that accident name, famous Hindenburg or Heidelberg accident was there, right? Big argon based
Ah.
that I'm unable to recall the name, but that is a blimp structure, I think. Yeah, this Goodyear. What is the name of this? I don't know.
Yeah, I think this was the article. Maybe they've mentioned. I think they did mention it. I hit it here somewhere, right? Yeah, here Hindenburg.
Hindenburg.
Incinerating. Yeah, at Lakehurst. Okay. Yeah. So here, this is actually, these points are not my own. So we discussed our points here, but these points are actually from this blog, right? So I've taken all these points from here and from other like official resources. So here they have actually considered it. So it is a discussion. Whether they would be whether a rigid kind of a structure would be suitable or a blimp kind of a structure would be suitable. Does the structure need to be connected? I think this is also a point. So the structure internally that we have, how rigidly do you think it should be connected to the outer membrane? This is also one question. And then battens on a sail, tensegrity. Okay, I don't know what this is. Compression structure, skeleton, endoskeleton or exoskeleton. I think endoskeleton, since we are focusing on the softness of the robot. I think endo would make sense, right? An internal tensile structure, compression structure should be inflatable. Kite for kite sailing has inflatable forward edge. Okay, so yeah, these are just points to support this. Yeah, and anything anyone wants to comment on the skeleton, or you have some new ideas or something that you want to say? Okay, and about material also, uh, elastic versus plastic. So silicon type, which they have used actually in one of the prototypes, versus the more plastic structure of bean bags. Now uh, this can be like discussed. Which would be better, an elastic kind of a material or a plastic? Uh, so anyone wants to suggest, wants to make a suggestion on this? Okay. Uh, so yeah, I mean, my personal view is silicon type structure, since yeah, since it's also huggable and it has to interact with the humans on a general basis. I think this makes more sense. So this is, if it is a bean, if it's more plastic of a structure, I think that would also not be bad of an option, but I guess like elastic would be more suitable. Again, I think these are like specifically dependent on the application that is chosen. And about joints can be defined by where a rigid skeleton can bend, and they can be defined by concentrations of deformation in soft structure. How can we make soft joints? In inflatables, this is easy to do, creating seams that close off a volume and allow a segment to easily bend. So this is, I think, about the same structure that we saw. How are they making joints? Here it looks more rigid, can be defined where a rigid skeleton can bend, or yeah, or they can be defined a concentration of deformations in the soft structure, soft joints. Yeah, so here in this one they've, I think, just used a rigid joint. How can we make soft joints in inflatables? This is easy to do by creating seams that close off a volume and allow a segment to easily bend. So this whole soft structure would be there, but it is bendable. And joints can also be created by internal membranes and ligaments, or by creases in the outer membrane, external tension. Yeah, so just the same point. And then again more points about the joint: flexures, ligament, rolling surfaces, electromagnetic actuation along rolling surfaces. These are like all of the things that they've considered in their ideation process. Standard actuation, pulling on tendons, motors, pistons. Again, I think we've discussed like what kind of actuators would be good. So now we can focus on the intelligence part. So I think this would be interesting. So from the video we saw that of course it is doing obstacle avoidance and object recognition, facial recognition, and then it is also understanding the inputs that the person is giving. So natural language processing, it is manipulating objects. It picked the stool and placed it to another location. So manipulation and grasping would also be points. Any points, any other inputs you want to add that probably I missed here?
I'll say one complete manual of human anatomy inside it.
Manual of human, so like, okay, uh,
That ability of telling that this bone, that bone. Now telling those names itself is a nightmare. So
okay. like a model, giving it whole model of the human body so it understands it.
Yes,
Uh,
yes,
and on another thing was that they are using a chip that stores the data, right?
yes.
For Baymax, and they are using machine learning, uh, and they're training the a model on 10,000 different medical procedures, as they mentioned. So but like this would be, of course, it's very vaguely put right in the movie. It's 10,000 medical procedures, but like what if we can imagine like a neural network, what would the input of that be, and what would the output of that be? Because like it's very vague, the problem, right? So maybe like identifying the conditions of the patient, so based on the images, maybe. So I'm just like hypothetically saying these things, so feel free to give your suggestions also. So maybe like let's say it does an analysis using the hyperspectral camera, and it identifies some conditions which are, let's say, stored in a matrix or some kind of dictionary or some format, and then based on this specific format it then points to which kind of medical procedure it should give. So kind of classifying different medical procedures based on the images, and then yeah, it says training for 10,000 medical procedures. So yeah, anyone wants to comment something about this? This would be, I think, interesting.
If you look at the clip, the the way he mentioned it is like the way Baymax identifies is it finds the problem. So one model will be a model or a method will be about identifying the issue. Now comes that 10,000 medical procedure. So the words where the Baymax that he said was that abrasion on your forearm epidermal skin. Now if he says that, which means he has identified the issue, that he needs to treat that epidermal skin, and he also recommends that if he puts that spray of that chemical, that will help. So like that 10,000 procedures if you put, it can be starting with rubbing a Vicks vapor up to giving a specific medicine. I mean, that's the simplest way I can think of right now to begin with.
So actually, like yeah, it can be anything. So it could be that it identifies the condition of the
Yeah,
patient, and then it does like a series of actions that form a medical procedure, right? So let's say
yeah,
applying a balm or something like that.
yes, 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 yes.
And it's like there could be I don't know, a vector way of a matrix, maybe a matrix of the relevant
Procedures.
sensor input. So yeah, maybe one could be like, let's say, just temperature, or one could be yeah, the x-ray kind of reading. So all these kinds of things, it just does the observation of the person, and then it suggests that if there is a condition or not, and then it does those medical procedures. I think yeah, this is like.
I think we can make it in this way that to train 10,000 medical procedure, we can say it in this way that Baymax can identify 10,000 types of problem the human skin can have. Sorry, human body can have. Okay, for which he have 10,000 this available solutions available.
10,000 conditions.
Yeah, he can identify 10,000 problems. Burned skin, rash skin,
Yeah.
cut mark, things like that. He can identify this 10,000 symptoms, and for every symptom he has a solution available.
So actually, I think like there's like also so this would be so one would be like capturing all the different kind of inputs. So let's say just image, temperature, all these kinds of things, and then it actually represents it. So making a representation would actually be the input. Because
Yes,
like if
yes,
you think about it, like let's say it's trained on different persons, right? And an image would be different and other things would be different, but then it represents it so that for it is independent of the person. Does it make sense?
yes.
Like a common kind of a representation is there, uh, such that it's, yeah, it can be generalized, I think.
Like if you put it in a simple thing, take the same example. You get a burned skin. You get a burn on your forearm. Then the way he's been trained is to identify what a burn looks like.
Yeah, yeah, yeah.
Okay, identify and look. And once he knows what a burn looks like and where the burn problem is, then you have a matrix available which tells, okay, do these steps and it should be good enough.
Yeah, 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 yeah. So this would be like, yeah, this is, I think, just in its internal storage. So this would be the machine learning part, and then it's just like the manipulation part of performing the medical procedure. And here also the sequence of actions here actually, interestingly, the this is just sequence of actions, right? And
Yes,
this can also be done by using, uh, there's something called task planning, which we've talked in one of
yes,
the older meetups, I think.
yes, yes,
So
yes.
this is just,
Descriptive.
sorry.
Yeah, you we had this descriptive language based
Yeah,
idea,
exactly,
task
exactly.
context.
You remember it like
Yes,
PDDL, exactly. So yeah, just to maybe reiterate, it's just in PDDL we define the problem and we define the domain, and the domain would give an idea of the structure, and this is just to give an idea of the surrounding and the problem, and then this is fed to an algorithm, and then the algorithm would actually determine the sequence of actions rather than you manually defining. But yeah, it could be any of the things, right?
yes,
And let's see, what do we have? So computer vision based, I think, object detection, then grasping, natural language processing, alerted after sound out, and it scans for symptoms using the camera, allergic to, yeah. So there's also deactivation feature that we saw, right? It does not deactivate until it hears I'm satisfied with my care. Yeah.
mm,
Okay, now this is the last part is about social interaction. So we saw about the physical aspect of this robot and about the uh, how the brain of the robot might be, how the algorithms behind those might be, and uh, now about this I didn't find much information, and I think this is also the most difficult part of the three. I think as Chris Atkinson, the professor, also mentioned that the physical part is the easiest of these, and the social interaction part is the most difficult one, because there's still ongoing research that, yeah, it will still take a time till it makes some significant progress. So human robot interaction is one part, then collaborating, safe environment, monitoring human behavior, study. Yeah, so this is one thing that I just found, is that there are multiple two possible ways it can do human robot interaction. So one is learning from its actual interactions with the humans. So the robot learns with from its own interactions with the human, and the other thing is it can study human to human behavior. So we would feed the sort of a data where human and human behavior is encoded in some way, and then that learning would be transferred and then applied to human robot.
do you want a best example for this?
Yeah, go ahead. What example do you have?
Please don't laugh, huh?
No, 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 go ahead.
Do you remember that movie Chitti Robot? It's
Yeah, yeah.
basically human to human behavior transfer learning.
How is that? Sorry, I don't remember specifically, but I know which movie you're talking about.
Yeah, so in that he basically learns the way everybody behaves and he
Ah, okay,
adapts
okay, okay.
accordingly.
Yeah, yeah,
That and that is where the entire problem comes in. So
yeah, yeah,
Hello.
yeah. Yeah,
Especially
that's a funny example. But yeah, yeah, that paints the picture of it. Yeah, but yeah, I didn't find much information about this specific to Baymax. Anyone else wants to add something about social interaction part of it? So, so the thing about this is also that the interface would play a major role. And actually, there's an app called Baymax that I also saw. Let me quickly search about it again. Baymax app, and it's kind of inspired from
nice.
this itself. Baymax mobile app. I'm not sure if I'm able to find the one that I saw right now. Just a minute. Let me see the references. I think it should be here. Nah, I don't think I saved that. But anyway, there's an app, Baymax app, health care. Yeah, I think this is the one. A personal healthcare companion who lives in your phone. Say hello to Baymax. So, yeah, this is actually they've named it on this. The idea is pretty simple. Like we need a personal healthcare companion, someone who can help us medically when we need to. So this is the whole idea. Good morning. How are you feeling? So it takes yeah, the mood feedback like we saw in Baymax. And let's see what else does it have. We need a personal healthcare companion, someone who can help us medically both by providing us right information to us and helping us get in touch with the right medical professional. Actually, this is a very uh, good thing to debate about. Do you really need a physical robot, or do you think like this can serve the need and maybe it can connect you to the right doctor or something, and maybe yeah, such a robot is probably not even needed.
it will depend upon the amount of shock the patient is in.
What do you mean?
I mean, like, come on, if person is really hurt and
Yeah,
cannot
yeah.
concentrate, it will be difficult to operate a
Uh,
mobile at that point of time.
no,
But if
but
a robot,
like there are ways to design the user interface such that maybe in an emergency button they could just, let's say, press the side button or just say something and it triggers so
yeah, calling it will be like calling 109 and telling everything,
yeah, so
and
it
then
could
you
be
figure it
just
out.
like okay, you say okay Google or hey Siri, so it could be like help or something like
Ouch.
that, ouch, or yeah, so it could be the same concept but it would be on a phone, and I think that
Mm-hmm.
also makes sense.
But then again, it will be just what you call just a
Such,
diagnosis,
yeah, yeah,
but
yeah, but
it
yeah,
will lose the
application.
purpose of
Hmm.
first responder.
Yeah, yeah, no, that is right. No, that is for sure true. Um, so here also Baymax will tell you how to make the swelling go away. So it can only give you, yeah, phone can only do so much. It can give you suggestions on how to make the swelling go away and will help you get well by providing a treatment. If that doesn't work, Baymax will connect you with a doctor and schedule an appointment with her. So till the time we don't have this kind of a robot, like this app might help, right? When you open the app,
It's I can put it in this way. It's a medical chatbot.
you... Uh, not exactly chatbot, because chatbot would be something different, right? It's just taking uh, your feedback on the specific things that it wants to know, and then it
Mm-hmm.
suggests you. So
Yeah.
chatbot
So,
would be like more uh, open ended, I would say.
okay.
Yeah. So there's another chatbot, but what was the name of the app? Replica. Have you guys heard about it? On a different note, right? Replica app. This is a very different. This is an actual chatbot. From chatbot, I got reminded of this. But maybe we can have a theme about chatbox and NLP at some point, and we can discuss about these things. So it's like you can actually chat, and it actually learns your own typing patterns or something, and it becomes your friend. So it is helpful in the case of people suffering from mental health issues, depression, loneliness, all these kinds of things. So this is one AI companion. Who cares? So this is the idea about chatbot, but this is not a chatbot, I think. Yeah.
Uh-huh.
Yeah. Apart from this, yeah, I think we are done with today, and then there are some really good resources that I can share. So there's the entire PhD thesis of this person on whose work this Baymax idea is inspired. And this would be interesting for those of you who have time. Just you can go through it. It's a long thesis report there. And apart from that, these are just some. I'll share it in the server after some time. So this one here, soft inflatable robots for safe physical human interaction. So this is the like main idea that Disney actually took inspiration from. So this was actually the main thesis work. So introduction, then motivation. So this goes in a lot of detail, and you'll be able to understand things very deeply from this if you go through it. I'm looking for some images and stuff. Prototype of a 2 active degree of freedom continuum arm. So yeah, so this is the kind of so continuum arm feeding a subject. So this is the kind of research. So someone was saying, I think Vansh was saying that, right? That is there an actual work going on? So this is the actual work that it is inspired from, the Baymax idea. Okay, anyway, this is for if you're interested in this. Yeah, so that is it for this meetup. Thanks a lot for joining, guys, and now we are open to casual discussions, and maybe let's begin with feedback session on how do you think it was. So yeah, maybe let's start with Super Godivan or Akshay. Maybe you can start first.
I came after a very long time, so I'm
Yeah,
still,
yeah,
settling in.
yeah. You came after a long time. It's good to see you. Are you very busy these days? Let me
Yeah, actually, I
stop.